So for this next section, we're going to talk about inverses and specifically how to find the equation of the line or the graph that would be the inverse of the function that they give you. So in the past, you've talked about inverses with addition and subtraction and then multiplication and division, kind of using the inverse to help you work with a certain problem. So like for addition and subtraction, those two operations would be inverses of each other. Think about that as like being opposites, okay? So the opposite of addition would be subtraction. The opposite of subtraction would be addition. So you can kind of go back and forth. Multiplication and then division would also be an example of inverses. You've also seen inverses like when you found reciprocals of numbers. So if you were trying to get rid of like a fraction from a problem, we always talked about use the reciprocal to do that. And so the reciprocal is technically considered to be an inverse. Now we're going to take this idea of inverses and apply it to functions, to graphs, and find new equations for those so that we can graph both the original and the new one. So in order to do that, there's 4 steps that we need to follow right here. The first step is to replace anytime you see f of x, so that f with the parentheses x, that's like that function notation, replace that with the letter y. Just get rid of it altogether and put a y in its place instead. Step 2 is to take your 2 letters, your x and your y, and you make them switch positions. So you just flip-flop them. So you don't change anything else about the equation. You don't move any numbers around. You just change where the x and y are. They just change out each other. Then after you've done that, for step 3, you solve it again so that you have y by itself. So this is when you'll have to start moving numbers around. You'll have to add or subtract, multiply or divide to get that y by itself. Then you call that new equation f with a little dash next to it. So it's like a little, almost like a, you know, what you would see like if you're writing like can't, you put that little apostrophe in there. It's called in math prime. So like we would say this is f prime. And so this is just referring to it's the new function. That's the inverse of the original one. So it's just kind of a little bit different notation so that somebody doesn't assume that it's the same graph twice. Then we can graph both of them, whether they're straight lines or if they're quadratics or anything else like that. And we can use t-charts. And I'll show you how to do that because there's a really easy way to do this. So let's just do one together first. We're going to start by just finding the inverse. We're going to save graphing for just a minute here. So step 1, if I follow my steps up above, is to replace where it says f of x, change that so it says y. So this is now going to say y equals x plus 2. Okay, step 2 is to take my x and my y, so up here in my equation where you guys see y and where you see x, you need to flip them around. So instead of it saying y equals x plus 2, it's now going to say x equals y plus 2. Step 3 is to solve this equation for y. So right now, because I rewrote it, it says y plus 2. How would I get rid of this plus 2? Subtract it. So I'm going to do minus 2, minus 2. Okay, now I'm going to go ahead and put y first and just kind of take this and reverse it a little bit. I like my y to come first in my equations. Now what's left on the left side here was that x, and we had to subtract 2 from it. So now it's going to say y equals x minus 2. Okay, and then the last step is to switch out that y with that f prime of x so that we're talking about its inverse. Okay, fairly simple. Now if they start having like squares and those kind of things, you will have to do a little bit more work with that. You'll have to start rearranging and square rooting some things, but that one's just a pretty simple basic linear function. Now underneath this here in your guys' notes, it wants us to graph both of them. It says graph f of x and your inverse function. So that means from up here, we're going to graph that x plus 2, and then we're going to graph this one here, that x minus 2, because these would be inverses of each other. Okay, so let me show you how I do this so that it makes it really easy for you guys in the future. So if we come down, you guys should have a graph already in your guys' packet for you guys to use. Okay, I'm going to make two separate XY charts. One of them is going to be for that original function that said x plus 2. The other one is going to be for our new function which said x minus 2. Okay, and I'm not going to get super fancy here. I'm just going to put in a couple numbers. And I'm just going to go off of my first one. So up there where it says x plus 2. You can pick any numbers you guys want. Okay, I don't care what numbers you pick. I'm going to go with 1 and 2. Okay, and then I would plug that into my function. So it's the x value plus 2. So what would be 1 plus 2? 3. What's 2 plus 2? 4. Okay, here's how it's going to make it really easy for you guys. I'm not going to put 1 and 2 down here. I'm going to put 3 and 4 here. So tell me, if I put in 3 in my second function where it says x minus 2, if I put a 3 in for x, what's it going to equal? What's 3 minus 2? What do you guys notice about those numbers? Every single time it'll be flip-flopped because they're inverses of each other. Okay? So notice how my numbers up there, it goes 1, 3, 2, 4. And down here, it's the same numbers, but they've flipped. My x's became my y's. Okay? They switched positions. And that should always happen when you're looking at the inverses, that those points basically just flip each other around for the new function. Okay, so now I'm going to graph both of these. So I'm going to start with that first one, which said x plus 2. So I've got a point at 1, 3. And I've got another point at 2, 4. Okay, now you could also use like what you guys have learned about graphing straight lines. Like that slope would be 1 over 1. So each point's going to go up 1, right 1, up 1, right 1, up 1, right 1 for the rest of its life. Okay, so this is going to keep going. It's just a straight line. For the second one, we have our first point's at 3, 1. And the second point's at 4, 2. Okay, and so this is also going to be a straight line, has the same slope. Okay, so remember this top one is like my f of x, and this bottom one is my f prime of x, my inverse function. Now what's really happening here is there's this line that's called y equals x. Okay, that line goes through the origin, so you don't have to draw this in, but I'm just going to show you what happens here. It starts at the origin, so it starts at 0, 0, and its slope is 1 over 1. So again, it's going to go up 1, right 1, up 1, right 1. So I'm going to draw this in using a dotted line. Because what's really happening with the inverses when you're looking at their graphs is they're being reflected over this red dotted line here. This is acting like as a mirror for both of the graphs. We call it like the line of reflection. And so when you're doing these inverse functions and you're graphing them, if you draw that line in on every single one of them, it's not necessarily always going to look like this, where you have a line on either side of it. But what it should be doing is reflecting one of the lines over it to get you the other graph. So there will be some cases where your lines cross. They don't go like parallel like these ones do. But if you draw in that red dotted line, it's acting like the mirror of reflection for it. Okay, remember when you guys look in the mirror, whatever is on you or whatever your shirt says reflects back in the mirror. It's just backwards. So that's what's happening here. Everything just flips over that red line. Okay, so on the next page there for you guys, it kind of talks about this, that an inverse is a reflection about the line y equals x. So it just takes all those points, it reflects it over that line and gets you like a mirror image of it. The order pairs switch around, so they just flip on every single one. That's why if you start with one of the equations, pick some points that are easy to work with that first equation, especially if you have like a fraction involved. Pick points that are going to work well with that first one, and then you don't really even have to do the math on the second one, because you can just take your points that you had from your first XY chart, put them down in the bottom one, just make sure that you flip them around. Okay, so let's do one more here together, and then I'll give you guys that last one on that page to try. So it says find the inverse, and then graph both of them. Graph the original one and graph the new one. Okay, so this right here is our original. F of x equals 5x minus 7. Okay, so you guys walk me through this. What's the first thing you should do? What's step 1? Good. Switch the f of x to y. So it's going to say y equals 5x minus 7. What's step 2? Not yet. You got to do something first before you try to add 7. Kind of. Like, so you're saying take the y and the x and do what with them? Flip them. Okay, flip your x and your y around. Now solve for y. So the first thing we have to do is what? Add 7. So this one's got an extra step, because it's not just as simple as adding a number over and you get your y by itself, because we have 5 times y. So now I have x plus 7 equals 5y. What do you guys have to do next? Divide by 5. Okay, so I'm going to go ahead and write this out now. So again, like the last one, I'm going to flip it around because I like y to come first. Okay, so y equals, because that's gone, the 5s are gone. Now you can either leave this as just one big fraction, or if it's better for you to like split them apart so it says x over 5 plus 7 over 5, you can do that too. I'm going to go ahead and just leave it together, so it just says x plus 7 all over 5. Okay, and then the last thing I need to do is rewrite it so that it says f prime of x equals x plus 7 over 5. Now we do still need to graph these, so I'm going to make my two xy charts again. Okay, now if you thought to yourself, oh, that has a fraction in it, I really don't want to deal with that. You don't have to. Okay, look at your first function, pick two numbers, any two numbers that you would like. So if you want to go with 1 and 2 again, or even if you want to do like 0, 1, and 2, if you want to add in a third point, you can. I'm going to go 0, 1, 2 here. You can do as many points as you'd like. These are going to be easier because we're going into that first function. That didn't have any fractions with it. Okay, so we're going to do 5 times 0, which would be 0, minus 7, which is negative 7. What's the answer going to be when you put in a 1 for x? Negative 2. How about when we put in a 2? Good, 3. Okay? What do you do on the next one? It shouldn't require you to do any math. Like there's no plugging in necessary. You just have to do something with these numbers. Flip it. Okay, so instead of it going 0, 1, 2 underneath the x, I'm going to put -7, -2, 3, and then 0, 1, 2 follows. Okay, so I got those same points and they flip around because that's always going to happen. And you could check it if you really wanted to. Like if you put in a -7, -7 plus 7 is 0. 0 divided by 5 is 0. So that one checked out. If I put in a -2, it's going to be 5/5, which is 1. So it's all making sense. So now I'm going to go ahead and graph these. Let's see, 0, -7. I have to come down a little bit. So down here. Then we had 1, -2, 2, 3. Okay, if you guys have like your lunch card or something, that works really well as like a makeshift ruler if you don't have a straight edge, instead of like trying to connect your dots. I'm going to do the best I can. I don't have anything like that to help me out, so I just have to kind of freehand. But if you guys have something, I would use it. Okay, so there's the first one. That's f of x. Okay, now the second one, we started at -7, 0. So that's going to go to the left -7, or to the left 7. -2, 1, and then 3, 2. Okay, and that's my new one, f prime of x. Okay, so these two do cross. They're not parallel like that first one was that I showed you guys. But again, if I wanted to draw in that line of reflection, I'm just showing you where that would be. This would be that line y equals x. You guys do not have to draw this line in, okay? I'm just showing you guys for class purposes here. This line is acting like the line of reflection. If you guys are looking at these 2 points, so take a look at this one where I'm pointing my blue arrows at. If I actually measured, like if I took a ruler here and I measured how far like this top point is to the dotted line and this other point is to the dotted line, if I made them like hit that line at a 90-degree angle, they would be the exact same distance away. And they look like they're the same distance away from that dotted line. Would you guys agree with that? Same with the other 2 points, like over here on the far right side, these two. Those look like they're the same distance away from that dotted line. So that's just kind of reassuring that we had these graphed correctly, because that line is acting like the mirror in the middle. Okay, so I want you guys to try this one. Try to do the whole thing. Write your new function, and then go ahead and try to graph both of them. All right, let's go ahead and go through this one together. Okay. Step 1 is to change it so it says y equals negative 4x plus 8 over 5. Step 2 is to switch your x and your y around. Now we have to solve for y. What's the first thing I should do? Times by 5. Get rid of that fraction by multiplying by the number that's in front of it, or that's like causing the issue here. So those 5's are gone. So now we have 5x equals negative 4y plus 8. What do we do next? It already has plus 8. So subtract it. So now it says 5x minus 8 equals negative 4y. And then we're going to do what? Good, divide by negative 4. Okay, so I'm going to flip it around again like I've been doing. So it says y equals this 5x minus 8 all over negative 4. Okay, and then last thing is to switch it out. So it says f prime of x. Now again, you guys can leave this as like a big fraction. If you would rather separate it out, you can do that. It doesn't really affect the answer at all, whether you leave it as one big fraction or if you put each number over that negative 4. If you do put it over, like each one over negative 4, just make sure that you simplify if you can. All right, so our two functions here, one of them is that original which said negative 4x plus 8 all over 5. And then the other one is our new one which says 5x minus 8 over negative 4. Okay, now as far as putting numbers in here, because you're dealing with fractions, you're going to, if you want to avoid getting fractions as answers, because fractions are like decimals that you have to round, they're not super easy to graph because you don't know where they're supposed to be at. So it might be best if you take some time and try to find some numbers that are going to work better with your problems here. Okay, so for example, for this first one, let's say I put in positive 2. Okay, if I put in positive 2, what's negative 4 times 2? Plus 8. 0. What's 0 divided by 5? 0. Okay, so then I would do some more thinking. I'm going to take negative 3 in here. What's negative 4 times negative 3? 12. 12 plus 8? 20. 20 divided by 5? 4. Okay, so I avoided my fractions there by strategically picking specific numbers. Because I kind of thought to myself, if I put this number in, am I going to get a number that's divisible by 5? Okay, now you guys can obviously put in whatever numbers you want. You just may get fractions or decimals, which is fine, as long as you're okay with graphing those kind of numbers. Okay, so then what I'm going to do down here is just flip these numbers around. So I'm going to put 0, 4 underneath my x, and 2, negative 3 underneath the y. And now I need to graph these two lines. Okay, so I'm going to do this over here. So I'm probably going to run into my work here, but that's okay. So I have 2, 0, negative 3, 4. That's for that first line. So this would be my f of x. Then the bottom one here, we have 0, 2, and then 4, negative 3. Oops. Let's try that again. So this would be my f prime of x. So those ones are fairly close together. It's kind of hard to see that they're inverses, but again, if I drew in that line that's kind of in the middle, and then if I look at 2 points, so if I look at these 2 points here, they're the same distance away from that dotted line, just like these 2 far away points are from that line. Okay, so that does still kind of go with this reflection over that line, that kind of mirror line there in the middle.